All right, hello, welcome everybody. Yeah, you enjoy your lunch, and we do a bit of work there while you're there, so enjoy it. We have, I think, a very interesting topic today, which is across the show here. It's cooling, and today we want to show you a bit on the two-phase direct chip cooling, and because we think it's quite a very interesting technology. My name is Thomas Schreiner, and I have Shahar Belking here. I'm working for Rittal, and Shahar is working for Sutacore, one of our partners, and he will take you through the technical of this presentation there later on. Thanks very much for doing that.
Thank you for having me.
All right. It's not going to work. There we go. Right, so you know Rittal maybe from the infrastructure side there on racks there, but we also do quite a bit on the cooling side there and other infrastructure products around the data center there. That's what we are dedicated to, that's what we're doing for our living, and that's what we have quite a lot of experience in the environment there. But for a strategic project like this one there, we have a good partner, which is Sutacore. On this one, they are really expert on waterless two-phase liquid cooling solutions there. So they are really focusing on CPU cooling there, based on two-phase cooling. And this is the kind of a partnership which we want to bring together and want to see what is the real advantage of this technology there. So starting off then, the trend of the CPUs, you can hear it everywhere. So the CPU heat load will grow in the next couple of years. There's AI is driving that particular there and other technologies there as well. So there's going to be a thermal problem in the data center. That's why you see a lot of technologies here to show there as well. And there's another trend. There's also to have more sustainability there and efficiency in the data center there. Therefore, it's also the trend to drive the CPU T-case temperature down there. So we have opposite things. We have on the one side we're growing, and on the other side we're going down on the T-case temperature there. And this is the kind of technology which we address now to solve this problem in a very efficient way and available. I think that's one of the key factors here. Shahar will now take you through the slides there, and will explain you how that's going to work.
Okay, hi. We're talking about two-phase cooling, but two-phase cooling is just the marketing name of it. It's actually dielectric cooling. And the important part of it is that it does the cooling of the direct-on-chip cooling without involving any water in the server and without involving a big change in the data center in the way data centers are being held today. So we need to move from air because the way Thomas showed you, the TDPs are going up, and there is just in the future, in 5 to 10 years from now, we won't see data centers that will be cooled by air because the CPUs will be so power demanding. And what we would see in a system like this, we call it two-phase cooling, is because the evaporators, the cold plate, instead of just being liquid in, liquid out, the liquid comes in, it boils inside the evaporators, and then it goes to a condensing unit that some call it CDU, we call it HRU, heat rejection unit, that condenses the vapor back into liquid and pumps it back into the system. So very simple loop will create this cooling effect that is needed on every single chip. What would a system like this consist of is three main components. There will be one is the direct-on-chip evaporators that we call ENEs, enhanced nucleation evaporators. It also has a manifold in the back of the data center, of the rack, that all servers are connected to the manifold, and the manifold is connected to a heat rejection unit. And what we have here is a heat exchanger, or the HRU or CDU as they're called. We have them on air, meaning they take cold air, condense it, and take hot air out, or based on water, on facility water, to condense the NOVEC. The main point and the main difference that Sutacore has brought into the market is the evaporator cold plate. This cold plate works on the chip exactly like a water-based one, but it doesn't include water. The liquid that flows inside is a completely dielectric liquid. There's no any chance of it hurting or harming the IT, the servers. The liquid that goes into a very thin tube, 4mm tubes. It fills in a pool. The technology is called pool boiling. It boils inside and vapor comes out the red tube that you can see there, and eventually only vapor comes out. What we see in the middle of the slide is that inside that evaporator there is a float that makes sure that the pool will be all the time full and that there will be no overflow. So liquid doesn't go in and out. Liquid only goes in and vapor only goes out of the evaporator. Me or you? So, what? Is that me or you? So when we're looking at a system, this is a full system, saying we have evaporators for different CPUs, different GPUs, from Intel, from AMD, and from others, and then the manifold that comes in different racks and sizes, and the heat rejection unit that we as I said, we have air-based ones and facility water-based ones. They can be on the back of the rack, like rear doors. You can see they're a full rear door or a half rear door, depending on the power that needs to be cooled. And it could be on bottom of the rack. We have a 6U air one, 6U water, and a 2U water that actually can cool up to 40 kilowatts of CPU power in a rack.
It's the video.
Yeah. We want to show you now a short movie that would show how the system actually works. So we all know how data centers look and how racks look. But now that the CPUs are becoming much, much bigger, meaning 270 and even going up to 400 watts, there will be a need to add, instead of the heatsink that cools it by air, the need to be is cold plates or evaporator cold plates, and that's what's going to be added on the CPUs right above them. It connects exactly like the heatsink was, same screws. There's no need to change anything in the server and anything in the rack. And then the liquid flows into these evaporators. And when the CPU is working and the heat comes up into it, it immediately boils, and the vapors are being collected back into the manifold and back into the heat rejection unit. The important thing to see here is that the servers don't change. The tubing is nylon tubing, very flexible, doesn't endanger anything, doesn't make any problems or any changes needed in the server. Connected to the manifold, it also is just like the PDU, does not have to change anything in the rack. And then connects to the heat rejection unit that in this video you see a air-based rear door with a buffer on the bottom and pumps that pump the liquid back into the servers. And we can get to a much higher density of having a 40 kilowatts IP power in a single rack, meaning triple or double CPUs in every U, making it very high. What you see on the bottom there is a 6U HRU air condenser. And here you see a 2U water-based condenser that would get the facility water and would condense the Novec. The important thing to understand that everything that flows inside the CPUs, inside the servers, is at the moment Novec 7000, the fully dielectric liquid. So even if we had a leak, it doesn't make any difference to the servers. What we see here is that the air that flows from the front and from the rear, from the cold aisle, could be up to 35 C, going into the rear door and coming out of the rear door after it already cooled the other components in the servers. Now it's you.
Right. Yeah, thanks very much, Shahar, for this, taking us through the technology there. So we see this as a real important technology to meet the issues which coming up, which are there, and also to adapt to several server designs, but also from the infrastructure point of view. And while we are here in OCP, so those units is also fully can be adapted to OCP from a mechanical point of view, but also from a technology point of view there. So this is, I think it's very important to take that with. Yeah, coming back, why two-phase? Because it's high efficient. We have a high efficiency achieving with that one there. It's a modular setup. You saw that in the video there, how this can be set up, and it's also scalable there. It's available. You can scale it in the data center there. It's a reliable technology. It has been proven. It has been tested in our labs together there, that this technology is there. And then certainly it's IT friendly because of the dielectric there, because it's the most fear having water in the data center. If there's a leakage there, you don't have to worry about that then. It's also maintenance friendly there with the setup there, with the technologies there. And of course, the solution is available there. We have solutions available for addressing that one there. So this, I think, two phases direct on chip cooling is one of the most efficient way of addressing the issues. So we would like to welcome you if you want to have further in-depth discussions how the process is going to work. We have a booth over there at just right behind you, booth B number 4 at the Rittal booth there. We have our colleagues from Sudacor there. We have also our team from Rittal there in terms of the infrastructure for the setup there. Thanks very much for your attention there, and yeah, wish you a good show, and for those who are traveling later on, have safe travels.
Thank you.